Hello and welcome to Maths with El Profe Lo, doing some elementary number theory and looking at some exam style questions. This question will deal with factorization. Okay, prove that any two consecutive Fibonacci numbers are relatively prime. Okay, so with any proof we need to define what we're going to use. So we're going to let f sub n and f sub n plus 1 be two consecutive Fibonacci numbers. Okay, and in essence what we would have is we would be able to say, remember that for our Fibonacci sequence we can say that f sub n plus 1 is going to be equal to f sub n plus f sub n minus 1, right? That a particular term in the Fibonacci sequence is going to be the sum of the two preceding terms. Okay, so we are going to let f sub n and f sub n plus 1 be two consecutive Fibonacci numbers, and we're also going to let d, right, the greatest common divisor, be equal to f sub n plus 1. So in other words, we're wanting to show, right, you could say, hey, we need to show that d is going to be 1 so that they will be relatively prime. Okay, so since a Fibonacci sequence is given by, right, a sum of two preceding terms, right, then we can say the following: that f sub n plus 1 minus f sub n has to be equal to f sub n minus 1. Okay, and if that is the case, the implication is, right, that my greatest common denominator is my greatest common divisor is a number that divides f sub n and f sub n plus 1. So it'll also divide the difference. So in other words, right, that if this is the case, right, I know that d must divide f sub n plus 1 minus f sub n, which implies that d must divide f sub n minus 1, right? That it must divide one of those preceding Fibonacci terms. Okay, and if that's the case, right, we can also say that f sub n plus 1 is going to be equal to the sum of the two prior terms, right? So therefore, f sub n plus 1 minus f sub n minus f sub n minus 1, right? And this should just be f sub n, right? So f sub n is going to be the sum of the two previous terms, right? So subtracting f sub n minus f sub n minus 1 is going to be equal to f sub n minus 2, right? Which implies that d is going to have to divide f sub n minus 2. Okay, and if we go a step further, we know that f sub n minus 1 is going to have to be equal to the sum of its two preceding terms, which would mean that f sub n minus 1 minus f sub n minus 2 is going to be f sub n minus 3, which would imply that d is going to be a divisor of f sub n minus 3. Okay, if I continue with this, right, if I continue through this process, then d is going to have to divide my first term in my Fibonacci sequence, which implies that d is going to have to equal 1 because f sub 0, right, has to equal f sub 1, which is going to be equal to 1 in my definition of a Fibonacci sequence, where f sub n then is equal to f sub n minus 1 plus f sub n minus 2, right, where n is greater than or equal to 2. Right? That's one way of defining the Fibonacci sequence, and it has to be the case that the greatest common divisor is equal to 1. Okay, so once I finish there, all right, then I can put my little finished with my proof, or I can put my little QED. Okay, so once again, to prove that any two consecutive Fibonacci numbers are relatively prime, we need to define our consecutive Fibonacci numbers. We need to be familiar with the Fibonacci sequence. Okay, we need to define what our greatest common divisor is going to be labeled as, and we know that we need to show that that greatest common divisor is going to be equal to 1 because we're relatively prime. Okay, of course, we do know, once again, what we did here was that we know that D divides F sub n, and we know that D divides F sub n plus 1, right? And that would mean that D is going to divide F sub n plus 1 minus F sub n. And that's the idea, that's the process that we're working through for each of these. And eventually we do need to stop when our term ends up being at 1. Okay? This has been Maths with El Profe Lo, so a little thought through how to prove two consecutive numbers are relatively prime.